All right, now let's look at a problem number 15. Okay, so problem number 15 is number puzzle. So we can start, let's start from the one on the right-hand side. Okay, so let's focus on the unit digits. So we have y minus x equals to x. Obviously, you need to borrow 1 from this x, right? You have to borrow 1 from here, and then basically 10y minus x. Okay, so you see, in order to get things like this, we have the following scenarios, right? You could have 0 minus 5, right? So this equals to 5. And then, or you can have, let's say 12 minus 6, you'll get 6, right? Okay, so this is, let's say y, this is x, right? Or you can have 14 minus 7, you get is 7, or you have 16 minus 8, you get is 8, right? Okay, right, so that's what you can do for this part. But meanwhile, you also need to have y plus x is also you get x in terms of the unit digits. Then if you look at the combination, so 0 plus 5, which is okay, so right? So 0 plus 5, which is indeed 5, but 2 plus 6, which is not, right? So this is 8. 4 plus 7, this will end up with 1, right? 6 plus 8, this will end up with 4. All right, so if you combine these two things together, what you have is 0 plus 5, which is 5, and 0, which is 10 minus 5 is 5. Okay, so from here, we quickly get y equals to 0, x is 5, so this is 5, right? So this is 5. Okay, so now in order to get rid of this, there's nothing here, so there's nothing here, right? Okay, so this is 0, so you get it's 4, right? Okay, so you have 0, 5, 5, 5, right? So this is 4, so you get the u is 9, right? So here, then we have figured out all numbers. Okay, so then I have x plus y plus z plus u. So let me put all the numbers here. So this is 5, this is 0, the z is this 4, and then we have the u, which is 9, so which is 18. All right. Okay. Next, let's look at problem 16. Problem 16, Bailey, a personal worker in the town of Cora, collect 8 buckets of cherries on his first day or each day. Okay, so he collect 8 buckets of cherries on his first day. Now each day after that, he increased the number of buckets he picked by 2 each day. All right, so then so this is day 1, day 2, day 3, and all the way to day 20. Right, so then each time increase by 2, so increase by 2, increase by 2, increase by 2, right? Okay, so the next one will be 10, and this will be 12. All right, so the 20s will be 8 plus, because from 1 to 20 you have 19 increases, so it's 19 multiplied by 2, right? And the 90s day will be 8 plus 18 multiplied by 2. Okay, so now let's rewrite the whole sequence. So what we have is 8, 10, 12, 14, and then all the way. So this one is 38, right? Plus 8, so this is 46, and this is 44, right? Okay, so that's what we have. Okay, so now what we want to figure out is the total number of buckets that he has collected in the first 20 days. So what that means, we need to find the sum. Okay. So here what we have, because each time increased by 2, we know this is what we have. This is called the arithmetic sequence, right? And there is some well-known trick to calculate the sum of an arithmetic sequence. That is called Gauss trick. So this was discovered by Gauss when he was around 70 years old. According to the story, so his teacher asked the whole class to calculate the sum from 1 all the way to 100. And then Gauss find the trick to do it. So let me remind you the trick. So say if we have plus 1 plus 3 and plus 4 and all the way to 19 plus 100. Okay, so what is the trick? The trick is you just do the pairs, right? So there are different ways to express this. One way is you can just look at pairs. Okay, 1 plus 100. So 1 plus 100 equals to 101. And then 2 plus 99. So 2 plus 99 is also 101. And then you have like 3 plus, this one's 8. 3 plus 98, which is also 101, right? Okay, so in total, then you have to say, okay, how many pairs do I have? So in total, there are 50 pairs, right? 50 pairs. And so 50 pairs and 50 pair times 101, so you get 50, 50. All right, so this is called a Gauss trick. And here is similar, right? So we just, because this is also arithmetic sequence, so we do Gauss trick. So we have 8 plus 46, and then you have 10 plus 44, right? So then you can have 12 plus, this is 42, right? Okay, so we have 8 plus 46, which is 54. And then we have 10 plus 44, which is also 54, and such and such. Okay, so how many pairs? Because in total we're 20. So we have is, okay, so we have 10 pairs. So we have 10 pairs, and each pair equals to 54. So the sum equals to 54 multiplied by the number of pairs, 10. So that's 540, right? So this is so-called Gauss trick, as I said. So this was first discovered by Gauss. It's a common trick to calculate the sum of an arithmetic sequence. Okay. All right. Now let's look at problem number 17. So here we have this picture, what we want. So we have 3 squares. They are put next to each other. So what we want to find is the area of this red region. Now, if you want to find the area directly, which means you directly calculate the area of the red region, then you need to use more advanced knowledge, like similar triangles. But we haven't learned those things so far. So what I'm going to do is we're going to use the simple cut and paste. Okay, so what is cut and paste? Right, so cut and paste is, we try to combine this with other easy shapes, right, to calculate the area. So we realize, okay, so there are different ways to do. I think for this one, the quickest way to do is you combine this red one with, say, the blue one, right? I think you put the blue one, okay? So you get, okay, so the red one plus the green one, sorry, I say the green one. You put together, this exactly equals 3 squares, right? So this is just 3 squares, right? Okay, so now we know this area. So this is 2 and 3, and this is 4. So the total area, right? So the total area equals to, this is 2 squared, right? So this is how we calculate the area of a square, is you just take the square of its side length, and then plus 3 squared, and then plus 4 squared, right? So that's what we have, okay? So this is 4 plus 9 plus 16. Okay, so we get this 29. So this is total area. Now I calculate the area of the green one. So green one is, so this is a right triangle. So this is right triangle, right? Okay, so let's see. So here we have the one leg is 4, so this is 4. And this one is what? This is 9, right? So this is 9. Okay, so we single this one out. So if I have right triangle, so here's 90 degrees. So this is 90 degrees. Okay, so this is 4 and this is 9. So we know the area equals to 4 times 9 divided by 2, which is 18, right? Okay, so well, one way to see this is you say, okay, I can just put a congruent right triangle. I just flip it, and then you just get a rectangle. So that's why it's 1/2 of the whole thing, right? All right. Okay, so then you get the green one. So this area of this is 18. So this one equals to 18. Okay, so I get the red one. So I get the red, let me summarize here. So I get the red plus the 18 equals to 29. So what is the red? So the red equals to 11. Okay, so this is so-called cut and paste. So here what we have is basically, we can say it's either way. Okay, so I can say I cut the 3 squares into 2 parts. One is the red part, another one is the green part, right? We can easily calculate 3 squares, and we can calculate the green part easily. And then we just use the subtraction. We get the red one, right? Okay, all right. Now let's look at number 18. So number 18, so here we have quadrilateral ABCD. So we know one angle is 120, and this one is 90 degree. Okay, so here ED bisects this angle D, and the EC bisects the angle BCD, right? So then we need to figure out is the angle of E. All right, so before we solve this one, let's recall some basic facts about angles of polygon. So first, some basic facts. So number one, if I have a triangle, let's say this is angle 1, this is angle 2, this is angle 3, then I always have angle 1 plus angle 2 plus angle 3. This is 180, regardless what kind of triangle you have. Now the reason, as we mentioned before, so you can draw a line parallel to this, then you get this is angle 2 and this is angle 3. So then if you put them together, you get this 180 because this is flat, right? All right, so from here, we can go ahead to deduce the number of angles for quadrilateral. So this is angle 1, this is angle 2, this is angle 3, and this is angle 4. Now you see, I can decompose this into 2 triangles, right? Okay, so each one is 180. So then from here, I can derive the angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. Now by the same approach, we can basically deduce the sum of angles of each polygon. All right, so for here, this is good enough because here we have a quadrilateral, okay? So then by this I have, let me put it here. So as the hint put it here, we need to figure out, so we have 120 plus 90 plus the angle ADC, so this one, and plus the angle BCD. So this is a BCD. So this is BCD. All right. So this one equals the whole thing equals 360. All right. So then from here we get the angle ADC plus the angle BCD, and this equals to, right? So this equals to 100. This equals to 150, right? This equals to 150. Okay, so if this equals to 150, so here's a bisect, right? So a bisect. So let's say if I put this is angle 1, this is the angle 2. Because it's half of it, it's a bisect. So this implies this angle 1. So angle 1 plus this angle 2 right here. So this one equals to 75, right? Because it's a half a bisect. Okay, so now then, because this one is 45, and we have for this one, if we want to figure out, is, let's say this, right? So this will be figured out. So the question mark, we know plus the angle 1, and then plus the angle 2, this is 180, right? Because in this triangle EDC. Okay, so then this implies this one equals to 180 minus 75, that's 105. Okay, so here we use, so here the thing you need to use is the sum of angles of a polygon. Now we start from the most basic one, so that's triangle. So triangle, if you have a triangle, regardless what kind of triangle you have, the sum of angles is always 180. Then we can look at the quadrilateral. The quadrilateral, I can divide into a quadrilateral into 2 triangles. So that's 360. Okay. All right. Now let's look at number 19. So number 19, so in a math contest that has 10 problems, right? So I have 10 problems. So let's say problem 1, 2, 3, 4, 5, and all the way to 10. So this 9, 8. All right. Okay. Maybe 6, 7. Okay. All right. So if a student gains 6 points, so if the answer is correct, then had 6 points. If the answer is wrong, then lose 1 point. Okay. So if Oliver answered every problem and her score, her final score is 32. So how many correct answers did she have? Now this is basically a chicken and rabbit problem, right? So it's because for chicken rabbit problem, it goes like, okay, so you know the total number of chicken and rabbits, and then you know it's the total number of their feet, and then try to figure out how many chickens you have or how many rabbits you have. So here you basically have correct answers and incorrect answers. Right? Correct answer worth 6 points, and the incorrect, you have to lose 1 point, right? All right, so there are two methods to solve this one. So method one, here's the method one. So method one is no algebra. We are not going to use any algebra. It's pure arithmetic. Okay, so what we can do is, so this is classical way to solve the chicken rabbit problem. So what we can do is, let's assume all answers are correct. So we assume all answers are correct. Oops. Okay, so let me put it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so if all of them are correct, then of course you get the total number score will be 60, right? Because which is 6 times 10. But nevertheless, the real score is 32, right? And there's difference. So what's the difference? So the difference is 60 minus 32, which is 28. So that means not all of them are correct. Some of them are incorrect. So we need to switch some from correct to incorrect, right? Incorrect. Okay. All right. So now you see, if I do one switch, say if I switch from one incorrect, let's say, correct answer is 6 points. Incorrect answer is -1 point. So if I switch from correct answer to incorrect answer, I basically lose 7 points, right? So it's -7, so it's a lose 7 points, right? Because if you switch from 6 to 0, you lose 6 points, but you have to get off 1 more point, right? Because it's -1. So then you get this lose 7 points. Okay, so one switch. So if I do one switch, so this is to switch, this is to incorrect, I lose 7 points. One switch, I lose 7 points. Now from 60 to 32 is 26. 28 is how many 7 points do you lose? 4. So 4 times this. Okay, so it's 28, which means you need to change 4 correct answers to incorrect answers, right? Okay, so then that means you have to change this 4 to incorrect. And this is the correct combination, right? So this is correct combination. Okay, so we have, so we get the correct answer is 6, right? So this is the classical way to solve the chicken rabbit problem. Remember, in chicken rabbit, what we do is we say, okay, we can assume all animals are chicken, or let's say all animals are rabbit. Then you get more legs than what is the real value. And then, okay, you need to switch some rabbits by chicken. If you switch one rabbit by chicken, then you lose 2 feet. And okay, so you just divide by 2, and this will give you the number of rabbits. So here's a similar, right? So this one, method one is no algebra. You don't need to use algebra. But you can, for some of you, if you have learned algebra, then you can use the algebra. So let's look at the second approach. Use algebra. Okay, so method 2. So method 2 with algebra. So what is algebra? Algebra is basically we use letters to represent numbers, and then we do we play like a combine like terms, combine the same letters, and then we solve equations. Okay, so things like that. Okay, so now if I use algebra, I can introduce that. I say I denote x as the number of correct answers, right? Correct answers. And then the number of incorrect answers is simply 10 minus x, right? It's just 10 minus x because the total number of questions is 10. If x is correct, then 10 minus x is incorrect. So from here, I can get what is the total score. The total score will be 10 times 6 times x. Sorry, so it's 6 times x because each correct answer. So let me remind you. So each correct answer is 6 points. Each incorrect answer you lose 1 point. And then you have to minus incorrect answer. So this is 10 minus x. So that's why because you lose 1 point, right? Because you lose 1 point. All right, so this equals to the 32. Okay, so now we combine like terms. So here I have 6. I have 6x. Okay, because here is minus. So, and you have a bracket, you have 1 to get rid of the bracket. Because you have minus, so when you get the bracket, you should change it, you have to change sign. So this will be minus 10 and will be plus x equals to 32, okay? So then I combine like terms. I have 6x, this x, so I get 7x, right? I combine like terms, minus, so this we call it combine like terms, okay? So then I get 7x minus 10 equals 32. So this implies 7 equals 42, so x equals to 6. We get the same answer. All right, so if you compare the two methods, you'll find in essence they are the same. But the first one is we don't have to use algebra. We assume they are all correct, and then we find difference one by one. And the second one is more robust, which means we have a systematic way to solve this kind of things. I just introduce a variable, then I set up equation, and then I just solve it, okay? All right, problem 20. So problem 20, so here we have Emily and Owen. They are going to library that is 1 mile from their house. Okay, so they leave home simultaneously. So Emily writes to, so this is the library. So Emily rides her bicycle to the library at speed, so ride bicycle at 12 miles per hour. Okay, so Owen walks to the library at a speed of 5 miles per hour. Okay, so this is Owen. Now, of course, Emily will arrive there early. The question is how much minutes does Owen, before Owen does Emily arrive, right? Okay, so let's see. So the total distance, this is 1 mile. Okay. All right, so 12 mile is 1 hour. So that's for Emily, right? So that's for Emily. We know 1 hour has 60 minutes, right? So 60 minutes. So 60 minutes for 12 miles. So what does that mean? That means 1 mile is 5 minutes, right? So if she rides bicycle, she can go 1 mile in 5 minutes. Okay, so this is for that. Now for Owen, it's 5 miles, 1 hour. 1 hour, right? So it's 1 hour. So again, 1 hour is 60 minutes. So this is 5 miles. Now 60 minutes for 5 miles. So that's 1 mile for 12 minutes, right? For 12 minutes, which divide by 5. All right. So this is for Owen. Okay. So that means if we change everything to to minutes, so we get Emily needs 5 minutes, and Owen needs, so this is 5. Owen is 12 minutes, so it's 12 minutes. Okay, so what's the difference? The difference 12 minus 5, which equals to 7. All right, so these are all about the first quiz. I hope that you have enjoyed solving these questions. For some of you, this might be the first time you have encountered such type of questions, and it could be tough at the beginning, which is completely normal. What I want to say is that please do not get discouraged and easily give up. If you stay on, I believe your ability of solving problems will be improved gradually and reach a new level at the end of this summer practice program. Okay, that's it, and have a nice weekend.